Hi guys, this is Ronnie, and for the discussion problems, I'm doing problem 7.29 and 7.43. Starting off with 7.29, two previously undeformed specimens of the same metal are to be plastically deformed by reducing their cross-sectional areas. One has a circular cross-section and the other is a rectangular. During deformation, the circular cross-section is to remain circular and the rectangle is to remain rectangular. The original deformed dimensions areas are as followed. Sorry about that. And then you have the data right there. So it says which of these specimen will be the hardest after plastic deformation. Now for these, I use the cold working formula, which is you take the original dimension minus the deformed dimension over the original dimension. So basically it's 1 minus the deformed dimension over the original dimension times 100, and that will give you your percentage. So I basically did for the circle one started out as pi radius squared of 15.2 minus pi radius squared of 11.4 over pi radius squared of 15.2 times 100, and for that I got a percentage of 43.74%. And for the rectangular one, which the dimensions were essentially 125 times 175 divided by minus 1500, or minus 75 times 200 over 21,875 times 100. Sorry, I didn't write the 100 there. That was my fault. And I got 31.42%. So this would mean that the circular specimen is the stronger of the two specimens after plastic deformation, which makes sense from an engineering standpoint as well, due to the shape. And for 7.43, a non-cold work brass specimen of average grain size of 0.008 millimeters has a yield strength of 160 megapascals or 23,500 psi. Estimate the yield strength of this alloy after it has been heated to 600 degrees Celsius for 1,000 seconds. If it is known that the value of Ky is 12 megapascals, millimeter to the power of 1/2 times, or 1,740 psi. Now for this one, I did the stress of y over stress 0 plus Ky d to the 1/2 power. And so the math I did was 160 megapascals plus 12 megapascals times 0.008 millimeters to the 1/2 power, and that left me with 161.07. But I don't think I did this one correctly, so if anyone wants to go over that and show me where I went wrong, that'd be greatly appreciated. And see you guys next time.